In this video, we're talking about inverse variation, and you'll also hear it called inverse proportion or inverse ratio. But when we talk about inverse variation, we're talking about two values that have a consistent relationship with one another, and when one of them increases, the other one decreases. Now, this is different than direct variation because with direct variation, either both things increase at the same time or they both decrease at the same time. When we're talking about inverse variation, one goes up and the other one goes down. The formula we use to model this is x equals k over y. X and y are the two values that are inversely proportional, and k is a constant that we use to describe the relationship between them. And you could see this formula written other ways. For example, you could see it written as a equals k over b, or m equals k over n. All these are the same. The important thing to know is just that x and y are the two values, the two populations, whatever you're describing, and k is sort of the relationship between the two. Now, with that being said, we've been given this problem which says the number of mice in a forest is inversely proportional. So because we have inversely proportional, we know we're going to be using this formula to the number of owls. If there are 300 mice when there are 30 owls, find the number of mice when the owl population is 60. So the first thing we need to do is decide which of our variables will represent mice and which one will represent owls. It doesn't matter which one we assign to which as long as we keep them consistent. So let's go ahead and say that x is going to be mice and that y is going to be owls. I always write this key down for myself so I remember and I don't end up switching things halfway through the problem and getting it wrong. So the problem tells us if there are 300 mice when there are 30 owls. So what we're going to do is plug 300 in for x since x is equal to mice. So we're going to say 300 is equal to k over 30 because there are 30 owls and y is equal to owls, and we've got y right here, so 30. Now these problems are almost always a two-step problem where we plug in the values we've been given, we solve for a value of k, and then we take that value of k along with the value we've been given in the question and we find the other value. So in this problem, we know there are 300 mice when there are 30 owls, so we've got 300 mice, 30 owls. We're going to multiply both sides of this equation by 30. We'll get 30 to cancel on the right hand side and we'll just be left with k on the right. On the left, we'll get 300 times 30, which is just going to give us 9 and 3 0, so we get k is equal to 9,000. So now with k equals 9,000, we've been asked to find the number of mice when the owl population is 60. So we don't know the number of mice, we know that owls is going to be 60. So we're going to go ahead and leave our x variable in the equation because that's the unknown variable we're solving for. So we're going to get x is equal to k, we know that k is 9,000, so 9,000 divided by y, which is owls, and we know that owls is 60. So we're trying to find the number of mice in the forest when the owl population is at 60. Conveniently, we just need to reduce our fraction, so we're going to get x is equal to, we'll cancel a 0, 900 over 6 is going to be the same as 300 over 2, or x equals 150. So there are going to be 150 mice when there are 60 owls. Now if we graph this, if we say mice and owls, we know that there were 300 mice when there were 30 owls, and we just found that there are going to be 150 mice when there are 60 owls. So we can see that we have an inverse relationship between mice and owls, because when owls increased, owls went from 30 to 60, mice decreased. Mice went from 300 to 150. So this is kind of a predator-prey relationship where when the number of owls increases, they eat more mice, and so the mice population decreases. The other way we can look at this, and these problems aren't always going to be this simple, but we were told that the owl population was originally 30 and then it went to 60. So we can see that when this happened, it doubled because 30 times 2 is 60. When the owl population doubles, the mice population gets cut in half. It goes from 300 to 150. So we've shown the inverse relationship. We know that there are 150 mice when there are 60 owls. If you want to, go ahead and choose owls to be x and mice to be y. Do the problem over again. You'll get a different value for k, but when you go ahead and plug back in for k and plug back in for owls as x instead this time, you'll just solve for y and you should still get the same answer. So that's always a way to double check yourself if you want to. Just change the assignment of the variables to see if you end up with the same answer.